Thank you. So, good afternoon, everybody. I hope you are full of the energy and you will not fall asleep after the lunch. So unlike my predecessors, I will be having a little shorter part as a lecture and longer part as a workshop. So I hope you will be joining me in the workshop part. I've prepared some artificial data for you to perform the analysis using large language models. So let's start with the URL where you can download the data. There's also the presentation, but it will be, I suppose it will be, maybe it was already somehow provided to you. So if you would like to do the same as I will do with the data, please go to the G drive and download. There are 3 files. One CSV file is called student data. So this is the main one that I will be using. And then there is other much larger file, exceedance. It's not necessary. You can download it as well, but this file I'll be just briefly showing in the other tool that I don't know if you would like to also register to it. So the first file, student data, is more important than the second one. So it does work. Is that so? Okay. Okay, so I'll start with some brief introduction or agenda. So I'll talk a little bit about some context about the possibility of using large language models for data analysis, and of course I will mention some safety issues. Then I will work with the sample data, so that's student score, small sample data set. We'll be working with some standard chatbots. Then I'm going to show you one of the example of specialized tools. I've chosen the service called Julius AI. Then it will depends on time. I also have topic about synthetic data generations, and of course some questions and discussion. So about generative AI as a data analysis assistant. So the capability of analyzing data is based on the capability of large language models to write the code. You probably know that LLMs can write a code and they are still better at it. This year, it was a competition between the top programmers and AI, and it was probably the last year when the humans won the competition. It was won by some Polish guy, and he said that the tools are really starting to be excellent. So probably the last year when humans win in the programming competition compared to large language models. Of course, they do not program equally well in different programming languages. The more well-known the programming language is, the better outputs are. So in data analysis, in general, machine learning, processing data, the main programming language is definitely the Python. And the models are also using the Python in the functionality called code interpreter. So they do not just type the code, but they actually run the code inside them. So, and this is the reason why we can, for example, analyze data, or we can build some small applications using LLMs, because they are actually running the code, not just generating it. They are running it and performing, and we can see the outputs of this run. So Python. It is the leader, so it was very well represented in the training data of the model. So, and the a greater amount of the data large language models have in their training phase, the better outputs are. Yeah, maybe I'm always asking in any lectures and workshops about what is your primary chatbot. So probably you can distinguish what chatbots are using the most. So whose primary chatbot is ChatGPT? Okay, yes, the majority as usual. And so whose primary chatbot is Gemini from Google? No one? Claude? Okay, great. And some, not all the hands were raised, so some other chatbot Grok or some open source models maybe. Okay, yeah, so it's usual that ChatGPT is leading, and it's also leading the market in general. I did not see some current numbers, but some numbers about half a year ago. ChatGPT was having about 60% of the chatbot environment. Yeah, but I think that now the competition is really Google with Gemini and with all its approach. It's starting to be, I would say, real danger for OpenAI and ChatGPT. Okay, so ChatGPT is your main chatbot. In general, let's say general usage, it is the differences are, let's say, very small. So for some basic usage and also for this purpose, data analysis, it does not matter if you choose Claude, Gemini, or ChatGPT. Okay, about some risks and best practices in AI data analysis. So, of course, it also, this is the rule which can be applied in general. Do not upload any sensitive data to public models. I hope this is something that all of you know. Even though there are some terms and conditions, and in ChatGPT, for example, we can disable this function that the conversations are used to improve our models. We do not know what OpenAI do with our data. So yeah, this is the general recommendation. Do not upload any sensitive data. So not just the data in the form of data set, but of course any personal, let's say, information about yourself and so on. Yeah, so this is connected with the first one. So if you work with data from some real people, you always need to anonymize it. Yeah, it was mentioned in the previous talk. So of course, it's not possible to upload data sets with some real people's data to public models. Other point. The models can generate the code, and if they generate the code, usually it works, because when there is some error in the code, the models always tries to make it run. So if there is some error, the model will generate the code again, and it will do as long as it somehow works. But the valid code, so if the code runs, does not necessarily mean that it is correct, that it was correctly translated from your request, which was which was formulated by the prompt itself. It's not clear, or it's not always true that the prompt was correctly translated into the programming language. Okay, so you need to check always this is also human oversight is mandatory. So, but you need to check if your assignment for the model was correctly done by the model. So review code formula, not just the summary. And large data sets may be truncated. There is something called context window. Do you know what's context window in related to LLMs? It is the maximum, say, memory or capacity of the text that LLM can go through in one feed of in one chat. So if you provide very large data and then you will talk with it, we will continue conversation. It may happen that you will run out of the context window. It is based on some maximum number of tokens. Tokens are the basic. This is the basic. Let's say unit for large language models. Models are generating tokens, not the words. So you can run out of it, and then the models may forget the beginning of the conversation, and you will not know about it. The models will not say you that I don't know what was in the beginning of the chat. They will simply not know that they do not know. But in the recent LLMs, the context window is quite large. In ChatGPT, it is 128,000 tokens, and in Gemini, it's 1 million tokens. So translated to something more relevant, I think that 1 million tokens is something around 6 full books, standard, I don't know, 300, 400 pages or something like that. But yeah, the data sets, they can consume the tokens relatively quickly. Okay, so that was, let's say, theoretical part of my performance. And now, what tools can we use? Or yeah, if you would like to do it together with me. So you can, as I said, you can use any chatbot that you prefer, ChatGPT, Gemini, or Claude. The results will be very, very similar. I'm using Claude for it because I also prefer Claude in these days a little bit over the ChatGPT. But yeah, it's not for any. Maybe from my perspective, the Claude and the creator Anthropic, they are the most transparent because they, for example, they are sharing their system prompt. That's something that in every conversation, a system prompt is something that is influencing the outputs. It's telling the model to be polite and so on, blah, blah, blah. So very, let's say, large sets of instructions that are incorporated in every answer. But the Claude and Anthropic is the only provider that is providing it transparently. It can be found. It can be found on their webpage. Okay, and then specialized tool. I'm going to use this service for. Yeah, of course, there are bigger number of services, but this is maybe the most known one. Yeah, for purpose of this workshop, the free version is sufficient. So if you would like to try it, just make the registration. You can use your Google account, and then you can have 5 data-related conversations per month in this tool. Yeah, I'm skipping some Excel usage, even though Excel is still one of the most important analytical tool. But just to comment it, so you probably know, you may know that there is a chatbot from Microsoft called Copilot, and Copilot is available not just a web page, but it's also available in Office 365 as an add-in. You can have it in Word, Excel, PowerPoint, Teams. So if you have access to this add-in in Office, then you can then the Copilot would assist you in creating the formulas in Excel or some in general with handling with the data. And there is also a new tool from Anthropic, Claude for Excel. So it's also add-on that can be installed into Excel from Anthropic. So yeah, so the companies are, of course, they know that Excel is still important and they are trying to somehow work with it. Okay, so I will go back to the presentation later, and now we can start with the data. So if you downloaded the data, let's briefly check it. So it's a synthesized artificial data set generated by LLM. Very simple data. I'm just going to so some artificial about the students. So we've got 7 columns, ID, and it is about the performance of the students. So we've got some preparation time, attendance, field of study, some final score from the test or the exam, and the age and the year of study. So it's 150 rows. Okay, before I download it to LLM and start work with it, if you check the data, if you downloaded it, can you identify some problems in it? Do you see some problems in the data? So there are several problems. I would say that 2 of them can be identified on, let's say, on the first sight. So, anyone? Sorry? Missing data? Yes. Okay, great. So we've got some missing data. Not much, but yes, there are some rows with missing preparation time and even the final score, which is the problem for creating, for example, some machine learning model. And other thing that can be easily identified, if you look at field of study, what is strange about it?
Information technology twice.
Yes, exactly. Thank you. Yes, so we've got 2 different names for one thing. One shortcut, IT and information technology. Of course, it means the same. So yeah, from this perspective, if it would be as 2 categories, it would not reflect the reality. Okay, so we've identified two problems. So let's start to work with LLMs. So as I said, I'm gonna use Claude, and now I simply drag and drop, move the file to the Claude. So I will add the file in here, and now I will start to ask about it. I have some remarks in here. So let's start with some basic overview of the data. It's not necessary to provide some sophisticated prompts. You can ask relatively simple way. So I'll start with something provide me the overview of this data set. Yeah, we can keep it like this. Yeah, and now okay, so I did not catch the code, but yeah, we can have. I can open the data set from this panel in Claude, and it's similar in ChatGPT as well. So I've got the data, and I've got some basic overview. So student performance data set, 150 records, data structure, column descriptions, eh, key observations. So because my prompt was very general, you never know what LLMs, because they are probabilistic models, so you never know what will they add in the general prompts like this. So I will see some key observations, missing values, inconsistent naming, okay, outliers. Yeah, so my second question was about the data quality and to identify some problems. So LM already, the Claude already, let's say, did it, but I will ask anyway. Can you identify the problems in the about the problems in the data? So I would say that main problems were already identified, but maybe it will come up with something else. Yeah, and now you can see the code in Python that is generated. It's already done. So it generates some code. It reads the data set, reads some basic info, identify data types. So this is the code which was performed, which Claude run, and based on the result, it will provide you this text summary. So it is not something that it is not as the standard conversation with LLMs that it will generate something. It will generate token after the token. It really do the analysis, which is based on the code. So you can copy the code and you can check it in your own environment. And if you run it in your own environment in Jupyter Notebook, for example, you will see that you will get some results out of it, because Claude also runs the code. And if the code would give some error, the Claude would not have the results out of it. Okay, so the problems identified. So we've got the missing values, okay, inconsistent category naming, field of study has duplicate categories with different naming, okay, data quality outliers, anomalies. Yeah, so we've got several students IDs with some anomalies. So student 71. He did some preparation, he have some attendance, but he scored just 7 out of 100. And there are some other outliers, student number 80 and 143. Okay, so some anomalies were identified. And so some, let's say, logical inconsistencies. I don't know why he named it differently. Not outlier, but logical inconsistency. So high attendance, extreme preparation time, but only 9 out of 100. So probably Claude thinks that this is not outlier, that this is just the error in the data. Okay, and we've got some recommendations. So we can proceed and we can because it seems fine. So standardize. So to merge IT and information technology, that's logical. Investigate students, okay. Handle missing data, sure. And verify students' 80s preparation time. So yeah, it's a recommendation for me as a data owner. So if I had some possibility to check the data, it would be up to mine, of course. Yes, so now let's do the data preparation. So let's try to handle these two main issues, which is the standardization and handling the missing data. So let's merge the categories. Keep just IT or merge like this, information technology to IT. And handling missing values, so let's do it very easily. So remove all the rows with missing, or we can let's make it a little bit more complicated. So remove the rows with missing student, or how it's called, student score, final score, with missing final score, and impute the missing values in it was the preparation time, is that so, with the average preparation time, yes, and impute the missing values in preparation time with average. Yes, so I'll clean the dataset according to our specifications, and again, we can check the code. So yeah. So data cleaning is complete. Here's what I've done. Merge categories, removed rows, imputed preparation time, and we've got the data set. It's yeah, it's not the full data set, it's 100 rows, but I can download the data and I can check it. And yeah, so as you can see, now I've got 146 rows. So these 4 rows with missing student score were removed. And the categories, yeah, there is just IT. There is no information technology. Yeah, so we can use it even for some data preparation if you don't know.
This file available in Claude, will it available like forever or disappear after a few days or something like that?
I think that it's kept in the conversations. If I'm gonna check some, let me check it. It's some more historical thing. 6 dataset overview. Yeah, for example.
You can ask the Claude about that.
I would not do that because the models usually do not know what they are capable of. So I've got a 28 days old conversation, and yeah, it's still in here. So there is some PDF file and the data. Yes, the model. Yeah, it's still in here. Yeah, I don't know. Probably there will be some limit because it would take a lot of capacity on their servers if everything will be stored forever. But yeah, I don't know. But as you know, as you can see, some, let's say, recent conversation 1 month ago, it's still in there. Okay, so let's go back to the, yeah. So yeah, so I've got the clean version. So let's say we've done some basic data preparation or data pre-processing, and we can continue to some exploratory data analysis. So let's have a look at the data. Let's do some statistics and visualizations. So provide me statistics for the numerical attributes and visualize the categorical ones. Again, it is a very general prompt, so if we would like to visualize it in some specific graph types, of course you can edit into the prompt. So yeah, now it's in Python. If you know the Python, you can see that it imports pandas and it imports matplotlib, also Seaborn, so some visualization packages, and it creates some graphs. Okay. Yeah. So statistics, mean, average, range, also some correlations. So correlation between attendance and final score is very strong. Age and final score also strong, and preparation time, attendance, preparation time, final score is, let's say, moderate. Okay, and we've got some visual outputs in the form of images. So some graphs. So we've got distribution of students by field of study. Yeah. Okay. Yeah, so maybe let's download it. Field of study, percentage distribution. Okay, it is the same. It's the percentage is already distributed in here. Distribution of students by year of study and students by field of study and year. So again, it choose something, and if you would run it again, the results probably would not be the same without some clear specification. Okay, so visualization. Yeah, I can ask for the correlation metrics. So create correlation matrix of numerical attributes. It was somehow it was somehow done by this text form, but let's have it in the proper form of correlation matrix. Yeah, so this is typical output, typical correlation matrix with the heat map. So you can see the correlations on the first side based on the colors. Okay, so we've done also some exploratory data analysis. And now we can, we will focus on the outliers. And I'm gonna ask about about the scatter plot between the preparation time and the final score. Create the scatter plot of with the preparation time and the final score. Because we like to check those outliers, and maybe it would be better to remove them. So this graph should show it to us. Yeah, so again, some overview, but I'm waiting for the visualization. So it's provided several visualizations of the model. Scatter plot with linear regression, scatter plot, yes, so four different versions. Yeah, and the outliers were mentioned again, and I'm going to open the graph again, and as you can see, these outliers are really or probably influencing the rest of the data a lot. So it would probably be reasonable to remove them. So I'm going to ask the model to remove these outliers and do the same thing again. So please remove the outliers and do the same analysis again and compare new results with the old one. So outliers, it's performing some methods to identify outliers, IQR method, for example, z-score. So you can see that it's combining several methods again without clear specification. It will do we don't know what. So it takes a little bit time because now it's creating a lot of code. Yeah, comparative analysis without examples. So this is the Python's outputs, and now after it's done, the results are somehow incorporated in the generated text to have the actual overview.
I have a question. AI is just an assistant, it's not something that you could rely on like 100%. We say that Claude or the Julius AI whatever are reliable data analytics tools.
Yeah, it's a hard question, but I would say that for the basic analysis like this, something that really was in the training phase, they saw these tasks for thousands and thousands times in different forms. So for the more the task is general, the probability that it would be fine is bigger. If you would do some, I don't know, some very specific analysis, very specific methods, then the probability that it would not make it right is bigger. For example, if in my one of my course, I'm using a very specific Python package, which was created at our department. And of course, when the students are trying to use this package, to use LLMs to work with this package, it does not work at all because it was not included in the training data. So the LLMs they do not know about it, and they actually they are not helpful with it completely. So, but with the packages such as Matplotlib, Pandas, and all of these things that the code is everywhere in Kaggle, for example, or many sources. I think that they can work with it very well. But you can never rely on it 100%. Still, you need to check the outputs, and if it's really important to use, you should also check the code.
I have a really quick follow-up. It's able to also learn in real time. So, for example, if I realize, okay, now I will need you to do some really complicated analysis, but I have data, I have articles or whatever else from previous researchers. Am I able to feed it and train it like in real time, and then I can expect it to perform like better analysis?
I'm not sure if I understand it correctly, but in general, the models are not trained in the real times. They are trained to some date, and everything you will provide, it's not incorporated in it. Because the training of the models such as ChatGPT, Gemini, it took months. They are training it for a very long time. It costs hundreds of thousands just for the electricity. And the NVIDIA graphics card on which it's trained on, it's millions of dollars. So the answer is no. It's the same as you. Yeah, I had some questions from the University of Third Age, from the seniors, and someone was asking me if you type something about yourself to the model, if all the other people can ask it, and they will get the answer about the person. So definitely not. That's not how the LLMs are working. Okay, so yeah, we've got the results out with or comparison with and without outliers. So it creates linear regression. You can see the previous, the old one with outliers and the new without them. So the model is definitely better. You can see the characteristics. They are much better, R and R squared. And yeah, we've got some overview in here. So overall impact, dramatic improvement. So you can see correlation R squared, very strong improvement. Impact by field of study, statistical changes, yeah, so on. And of course, what's great when using LLMs, you can ask for everything. So if you do not know what R squared means or anything that's in this output, you can ask, please describe what does it mean, what's R squared, and so on. So yeah, that's big advantage. You don't need to go to the web and search for it in a standard way. Again, these general things such as metrics about regression or classification, this is something that models definitely know very well. Okay, yes, so conclusion, removing just 3 outliers transformed the analysis, correlation increased from very to very strong, the predictive power increased threefold, and so on. Yes, so now we can create simple machine learning model. So it's already done some regression, but not, let's say, it was done because I asked for this correlation, attribute correlation. So now let's done it properly. So create linear regression model. I use 80% data for training. Predictors are preparation time and what attendance. Target is score. Okay, so let's create regression with these two predictors. So now it's using also the standard library for machine learning, sklearn. Yeah, so then lots of code. It is providing me some things that I was not asking about, but it's the problem with the general, let's say, very general prompts. So training set 114 students, test set 29 students. We've got the model equation, so equation of the regression, final score. You can see the equation. again, interpretation and the model performance. So the standard metrics for linear regression are R squared, RMSE, MAA. So model explains 94.8% of variance in test data, excellent generalization, high accuracy. So and also again some visualizations. Yeah, I can continue with, or my plan was to show also the classification, but maybe some time. So now let's transform the task for the classification. So for the classification, we need to have the target attribute in the categorical form, not numerical. So I asked the model to create to do the categorization with the student score. So I would, or maybe I can ask the model. I would like to do the classification with student. So classification, not the regression, with student score. What should I do? Yeah, so I need to transform the continuous final score into categorical ones. Binary classification, multi-class classification, and so on. So I've got advice how to do it. So I asked to perform create terciles for the student score. So I'm dividing the original numerical continuous data into 3 categories with the same frequency in them. Yeah, so it calculates terciles. And then I can continue with creating some classification models. So I'm going to use decision tree, which is one of the, let's say, basic and the best interpretable machine learning model. It can be easily visualized and it's comprehensible. Tercile, yeah. So low, medium, high. We've got the distribution of the students, 46, 46, 51. Okay. Would you, yeah, and Claude is asking if I would like to build a classification model. I can create logistic regression, decision tree, random forest, or others. So yes, please create decision tree. Do 80-20 data split. So I'm not sure if you know how the machine learning works, but this is the typical way we need to test the results. So we need to divide the data into training and test part. Training is used, or training part is used for the training model itself, and we are evaluating the model on the test part to know the performance. Yeah, so definitely we've got a very small amount of data, so 150 instances, so about how much? 120 something 115 will be used for training and the rest for testing. So very small sample, but just as an example, it's fine. Yeah, it's also providing me things such as feature importance. Again, I was not asking for it, but definitely you can add something as some to the prompt, something do just the thing I'm asking you, not omit everything else or something like that. But typically it's we can say that it is the things that it will produce are not irrelevant. So why not to keep it? Okay, yeah. So yeah, this is the example of some errors. So there is some error in the generated Python code. So the Claude was forced to generate it again. So you can see creating comprehensive visualization for decision tree fixed. So if there is some error, it will run it again and try to deal with the error. Okay, so I've got the results. So model performance, the performance on training set is not relevant. Performance on the test set is relevant for us. Yeah, so accuracy, every metric which I'm not going to describe is around 90%, so that's fine. Feature importance, so attendance is the most important, then the preparation time. Yeah, and again some overview, model strength, model weakness. And yeah, unfortunately it's on just one. It is on the single image, which is not ideal. But let's check the model itself. So let's check the decision tree. Yeah, so, okay. This is not very well formatted. When I was trying it, it was standard, standard visualization. So again, probabilistic models, we never know what they will output us. Yeah, so my point that decision trees are comprehensible and interpretable. In this case, it's not true, but it's just the form of it. So yeah, we can see that the attendance, so the most important borderline for the whole model is the attendance. So when attendance is lower than 78.5, then the score would be probably low. It can be seen on this part of the model. So in these cases, the performance is low, medium, and high. Okay, so this was my example of, let's say, very simple data. So we went through the whole process from know the data, so visualizations and some statistics, we started with the pre-processing, but the typical phase typical process would be to do the exploratory data analysis, know the data from the statistics and visualization point of view, then do some pre-processing, and then create some machine learning models. We change it a little bit, but as you can see, we can use standard chatbot for this whole process of creating machine learning models. Okay, so now switching to the, let's say, service which is specialized for these tasks. So as I was as I said, the service I'm going to show you is called Julius AI. So this is the page without, this is the page when you are not logged in. And you can try it, you can sign up with your Google account. And as I said, you've got 15 conversations with your data per month. Someone, do you know this Use AI experience? No one, okay. In general, I would say that for something like this that I showed you, so analysis of very small data set, it is definitely not necessary to use this service because it will do the same, it will do exactly the same as standard chatbot. So what are the differences of this service compared to the standard chatbot? One difference is the possible size of data which you can include. In standard chatbots, there is typically, they are limiting the maximum file size that can be uploaded. And it's in general, it does not matter if it's CSV file, it's PDF or anything. And it's typically something around 30 megabytes. So it's not possible to analyze a larger data set. This service, you can upload up to 30 gigabytes of data. And it's possible even in the free version. There is no limitation to the file size, but if you are not paying for it, you are limited by the number of conversations. So that's one difference. The other difference is that you can choose from that code interpreter that is doing the programming. In this service, you can choose from Python or R programming language. So you can set that you would like to have the code in R. And the other thing is that we've got many connectors. So you can connect to your data. You can see connectors. So you can connect to Postgres, BigQuery, Snowflake, Databricks, MySQL, SQL Server. So some connectors, some ways how to connect with your data, not just CSV file. Then you've got some kind of repository. That's true that you can, in chatbots, you can create some projects, or we've got also some ways how to do this. So, but in here you can upload many files, and then you can easily access them in the conversations and so on. We've got also two, let's say, main approaches. So we've got the standard chat. So this is the same as in chatbot, but we've got also the possibility of using notebooks. So if you choose notebooks, then it works as a notebook. So if I'm going to start new notebooks now, it's if you know the environment of Jupyter Notebooks or Google Colab, it is the same. So we've got these cells, and you can combine. You can use more cells, and then the tasks can be repeatable. So it's not as a standard conversation with the chat, when you run it once time and you cannot. Let's say you cannot modify it. If it's in the form of notebooks, then it's, let's say, more flexible. So these are, I would say, the main differences of this particular tool compared to the standard chatbots. But I've got this analysis. So in here it's in Czech, but in the form of chat, it is very similar. So I've got the code, some basic statistics, visualizations. So you can see it's very it's very similar. There are some exporting options, so export to Google Sheets directly and some other advantages. Yeah, for the notebooks, also there is also option or explore templates. So we've got some templates for the notebooks, and you can use something that was already prepared for you by Julius, so by the company itself, or by the users. There are some categories, so data visualizations, some quick visualizations, correlations, and PCA, charts. So you can, as you can see, cleaning, statistics, bar chart maker. So if I'm gonna choose something, so for example, let's do some statistical tests, significance testing. So I'm gonna select it, run notebook, and now the notebook is opened in my workflow, in my environment. Yeah, so it's very, very simple. So I need to add the data sources. I'm adding data sources from my repository, so from the files that I uploaded to the platform. So yeah, I've got the version of the data in Czech, so maybe I can upload also the English version. So let's go to the files and simply upload file. So yeah, students data, okay. Let's go back to the notebooks. And now I can add the data source. So students data. And now, as you can see, it is somehow prepared. So I've got this cell. What comparisons are you looking for? You don't need to know the name. You can just explain what you want to know. So this is the cell. It was prepared, and I'm gonna put my response. So let's say that we don't know anything about statistical testing. So I need to know. I would like to know correlation between student score and preparation time and attendance. Yeah, provide a correct statistical test for the date. Yeah, so let's run it all. So I've got 3 cells, one cell for loading the data, and then for somehow to deal with statistical testing and provide a correct statistical test. So let's run it all. Again, you can see the code in here. Sample of your data, correlation metrics, interpretation, final score with attendance strong and positive. So short answer, for correlation between score, preparation time, and attendance, the primary correct inferential tests are Pearson correlation plus test for correlation for each pair of continuous variable. So that sounds okay. What tests to use and why? Yeah. If you like, I can run the actual correlation significance test. Yeah, so now, yes, please run the test. Yeah, so again, you can see that there is not much difference between the standard chat version and notebook in cases like this. But as I said, it is much more I'm missing the word. Yeah, it's easily to modify it later when something is run, then you can go back and more easily change it than, because in the standard conversation it's something that's already it was already run, and you cannot go back and change something. Yeah, so I've got some statistical testing. What I ran, I treated Pearson correlation test. Okay. There is positive correlation, statistically significant, all of them. Spearman, also again linear regression, summary in plain language. So yeah. Okay. One more thing, you can also use the team version of this service, so you can somehow collaborate. But this is the service which is extra paid, even though you paid for standard subscription. The test version is something that you have to pay more for this. So yeah. Fine. So I've got something around 12 minutes. Let's go back to the presentation. So I've showed you how to do the analysis, and now a small part about synthetic data generation. So again, this is the functionality that LLMs can be used for, and again, I would say that they are good in it. So what are the typical use cases, or why to think about generate synthetic data out of the LLMs? So one, I would say the most important purpose is probably for testing of various systems. So you will have some systems and you need to test it, you have data for it, so you can help and generate your own data set using LLMs. So I don't know, for example, some sentiment analysis classifier, toxicity and content moderation, information extraction, some let's say standard machine learning models to test, or anything that's relevant for your field of study or your expertise. Other thing, help with data annotation. So to annotate data, it's very time consuming, and again, LLMs can be used for it, and probably they will do their work even in the case of for example, annotation of image data. So if it's not something very specific, some basic annotation they can probably handle. Solving data shortage. So to generate, if you have some data and you need to expand it, so you can provide the data and ask the model to generate similar data or generate data based on this short part, let's say. And also, for example, helping with the problem of unbalanced data sets. So a problem of unbalanced data sets is when your target variable is not equal, if these classes differs a lot. And from the perspective of machine learning, it is a problem that needs to be somehow resolved. We've got some standard methods generating, for example, smooth methods, oversampling, undersampling. But this when using LLMs, you can set the instructions by the prompt, so somehow influence the resulting data. Okay, so about this. So I'm gonna ask Claude to generate me some sample data set. So again, I'm going back to Claude, and yeah, I've prepared it. So now I not to think the prompt out of my head, so I'm gonna use it. So I've got the prompt: please generate a synthetic data set for sentiment analysis in CSV format. Include 200 instances. The first row is the artificial review of some general product. The second is the value of target, and the values are positive, negative, and neutral. So let's create it. And of course, you can ask to create it in JSON, XML. It's not a problem. You can generate it in any standard format. So on the data, it's very, again, general, so nothing specific: excellent, highly recommendable, amazing, poor. So simple, 2 short sentences. Yeah, 200 is maybe much. Okay. Yeah, and I've got the data. It's not telling me about the distribution of the target, so maybe I can ask, what is the distribution of sentiment? Okay, so then some, yeah, so yeah, it's completely balanced, 66, 66, and 66. Yeah, and now I can work with it. I've already prepared some classification using this data set, so I'm not going to create it now. I'm just going to show the results. I'm going to use this no-code platform, which we are using in some of our courses. It's called BigML. Now sign in. Okay, yeah. Maybe I've deleted it. Okay, so yeah, it's for about 3 minutes, so maybe I can I can create the model very quickly. So the data. Yeah, so this is not generative AI, but it's I would say very nice platform for the purpose of teach the basics of machine learning without the necessity of know the programming language, any programming language. So we are using it for some courses, not for, let's say, IT field of study. So I've got the source. I'm going to create a data set out of it. And I'm just going to split the data set into the training and test part and then evaluate the results. So now I'm gonna do the train test split 80-20. And I'm gonna create the model decision tree. Yeah, so this is the model. It's not important. We are interested in evaluation. So I'm gonna evaluate it. Yeah, so this is the result of the evaluation. Again, very simple data set on because of the, let's say, number of words that were used in the data. They were it was repeated, I would say. Let's check it. So yeah, exceeded my expectation. Terrible, I love it. So the number of different words is very limited, and that's why it works. Even though it's very small model, it's based on 133 examples. But as you can see, the classification works. Accuracy 85%. Again, the training set is very small, but it somehow works. Yeah, so this is the example of that artificially generated data set can be used for some test, let's say, test purposes. Yeah, and the time is nearly up, so I'm gonna thank you for your listening, and if there are any questions. Okay, so yeah, I'll be also there for a bit. So thank you.
Thank you very much for a very interesting presentation.
Thank you.
Now I'm delighted to present Katarzyna Martynowiczowa of Python for Innovation.